Hello, this is Mr. Stansbury. I'm going to take you through the 5 I notes on the standard deviation. At the end of this, you should be able to calculate the standard deviation of simple data by hand, and then also be able to calculate the standard deviation of more complex data on a graphing calculator. Alright, let's get started. So, first thing we want to take a look at here is what standard deviation is. Okay, standard deviation is basically it's the dispersal of the data. So really what it means is that it measures the difference between the scores and the mean. Okay, so the larger the standard deviation, the more widely spread the data is. And then conversely, the smaller the standard deviation is, the more compact it is, the more closely fit together all the data is. Okay, so to be able to calculate the standard deviation by hand, you have all of these lovely steps. And then it's all represented by this formula right here. But the first thing you do is you find the mean, and then you find the difference between each score and the mean. I'll show you how to do all this here in a second. Square each of your answers from step 2. Take the sum of all your answers from this here, step 3, and divide by the total number of scores. And then the last step is to take the square root of this step 4 right here. And again, this is the crazy formula. Okay, and I tried to color code it so you could at least kind of try to figure out what the heck it means. So standard deviation is, here's our square root. This crazy looking E here actually stands for the sum. So you're adding all the numbers. And then this X here is your score, and then you subtract the mean. So you're adding up all of these scores where you subtract the score from the mean, and then you square it, add those all up, divide by the total number of scores, and then square root it. Okay, and again, that looks confusing, and it really kind of is for taking a look at this. Let's break it down into steps. Excuse me, into steps, and I think that will help out a lot, make it easier. Okay, so let's take a look at example 20 from page 150. Okay, so it says calculate the standard deviation for the sample 2, 5, 4, 6, 7, 5, and 6. Okay, so here's the steps again from the previous page. So let's do this kind of piece by piece. Okay, so first thing we're going to do is let's find the mean. Okay, so we're going to add all these up. 2 plus 5 plus 4 plus 6 plus 7 plus 5 plus 6 gives us 35. Right, and then there are 1, 2, 3, 4, 5, 6, 7. So we divide that by 7, and we get 5. Okay. So first thing we did was find the mean. So step 1, we got the mean equals 5. Okay. Find the difference between each score and the mean. Okay. So now gets a little bit more fun. So we find the difference between each score and the mean. So let's do this. Let's do 2, 5, 4, 6, 7, 5, and 6. And then here, we'll write the mean down here. 5, 5, 5, 5 for each one of those. And then find the difference between each score and the mean. So let's just subtract these. And we get the negative is not going to matter. I'll put it on there anyway just for good measure, but it's not going to matter because we are going to square our answers, which is going to get rid of our negative, but let's leave it on there for now. 0, -1, 1, 2, 5, and 1. Okay. So we found the difference between each score and the mean. Now we're going to square each of our answers from step 2. So all of these here are going to get squared. oops, there we go. So this gives us 9, 0, not 6, but 0. That does not look good. This is 1, 1, 4, 25, and 1. Okay, so we squared each of our answers from step 2, so we're already done with the first 3. Take the sum of all our answers. So we got to add all these up. 9, 10, 11, 15, 25, 35, 41. So we get a grand total of 41, except for, oh look, crazy math teacher guy did this one wrong. Let's go back. This here, 5 minus 5 is not 5, it is 0. So that should be 0. That should be 1, that's better. 9, 10, 11, 15, 16, that's what we're looking for. Sorry about that. So we've taken the sum, we took the sum of our answers, and now we're going to divide by the number of scores. So we're going to take this 16, divide by the number of scores, which is 7. So we take 16 divided by 7, and we get 2.28, I think it was. 2.2, that's 2.29. Excuse me. And then we take the square root of that number. So take the square root of that. So we take square root of 2.29. Since that number is already in our calculator, let's just do the second square root of our answer. So I did second square root, second answer. And we get 1.51. I guess we do 1.512 is our standard deviation on that. Alright, so that's how to do it by hand. Now, I'm going to show you another way to do it on the graphing calculator. And actually many of your scientific calculators will also do this. You're just going to have to go and figure out how to do that, because there's so many different scientific calculators, it's hard to show you how to do each one. But again, what you can do is just look online. Just type in your calculator name and then just type in manual after that, and that will usually, you can download a manual. Sometimes you can even just enter in standard deviation on your calculator, type that into Google, and sometimes you'll be able to find it that way too. Okay, so to calculate standard deviation with a calculator, and in this case I've got the TI 83 plus. It's the same exact directions as the 82, the same exact directions as the 84, and the 84 silver and all that kind of stuff. So let's see what we can do with that. Okay, so first thing we're going to do here is we're going to pull up our calculator, and here's our sample. For the sample, 2, 5, 4, 6, 7, 5, and 6. Alright. So what we're going to do is we are going to go into the stat mode. So we click on stat, and you'll get this screen here, and we're going to enter this data in. So we're going to enter into, it's already highlighted on edit, so we want to edit it. And if you have any data in there right now, you'll probably, what you want to do to clear it out is highlight list 1 by using the arrows and hit clear. And then when you go back down, it'll be gone. And now we're going to enter this data in. 2, 5, 4, 6, 7, 5, and 6. Okay. So there's all of our data, minus the one at the top that you can't quite see, but there's all of our data. Okay, and then now what we're going to do is we're going to go back into stat again, and now we're going to use this data that we just edited. We're going to calculate, and it's one variable, stats, and that's already highlighted. So you push enter. There's only one list that we're working with, so you don't have to do anything else with this besides hit enter. And it now calculates our standard deviation. And there it is. Look, 1.5118 if you round that to 1.512, which is what we just calculated. So again, significantly easier with the graphing calculator. So by all means, use this. It's a handy little tool. Okay? Now also, you'll notice right here there's a little arrow that's pointing down, and it shows you a bunch of other stuff down here. Okay? I'm going to tell you what all these numbers stand for. So let's do this. Okay. So over here is our picture of, I took a little screen capture of what we had here, what we had on our calculator. So this here is our mean. So you can also use the calculator to actually calculate your mean or your average. This here, again, the E stands for sum, so that is that's the sum of all the numbers. So sum of all the numbers or the data. And again, you don't necessarily need to know all this here, but it's kind of handy to know. This here is the sum of all the data squared, which again, if you'll remember, we did all this. So sum of data squared, we'll call it. This here, this S of x, or Sx, this is your standard deviation if it was a sample. Now, if you actually look here, it says, I'm pretty sure the book has a little bit of an error in here because it says calculate standard deviation for the sample. So truly, this 1.63, this really should be the standard deviation if it's a sample. Okay, and then this OX, or this little, I can't remember what Greek letter that is. Anyway, this one right here stands for the standard deviation if it's the entire population. So if these are all the numbers, and that really is, this is the, the way that we calculate it, this is the entire population. So this really should be for the, let's change that to data, and that would make this make more sense. Okay, and there's a different way to go about calculating that. We won't get into that now. That's a bit too much for what we need right here. This N stands for the pieces of data. And then if you'll look here, look, we've got the minimum X, quartile 1, median, quartile 3, and the max. So look, this gives you all the data right here for your, this is your 5-number summary, isn't it? 5-number summary. Alright, so it's really kind of a handy little tool to use the TI graphing calculators, and it'll work on the Casios too. I'm not exactly sure how, but you can do it on that as well. Okay, so that's how you do it with a calculator. So let's use that on some more challenging problems, shall we? Okay, so find the standard deviation of the following distribution of scores. So very similar to what we just did. And again, I'm going to show you how to do all this by calculator. Doing this by hand takes a long time, and it's just not a real great use of time, especially when you have graphing calculators. And again, most of your scientific calculators will do this as well. You're just going to have to figure out how to do that. But I'd highly suggest doing it on the graphing calculators because it's fairly simple once you get the hang of it. Okay, so we're going to do the same thing we did before. We're going to enter our data. And again, we don't want this old data in here anymore, so we're going to go up, highlight list 1, and hit clear. Don't hit delete because it'll take the list out. Just hit clear. Okay. If for some reason you don't have these, like if yours starts with list 2 or list 3 or list 4, then you're still okay. Just enter your data in, and we can fix it at the end. But so here's what we're going to do. We're basically going to enter the scores here into list 1. And then we're going to enter the frequency here, minus the total part. We don't put that in there, into list 2. Okay? So let's do that really quick. 11, And again, to go to the next one, each time just hit enter and it will scroll down for you. Get to the right so that we can go to the next column. And then now we enter this in. So we got 3, 4, 5, 2, 8, 9, and then 5, 8, and 6. Okay, and all the data should match up there. Okay. Now we're going to go back into stat, and again we're going to calculate, and it's still just considered to be one variable, statistics, so we hit enter. And then now, before you hit enter again, we actually have two lists of data that we want to consider. So now what you want to do is you want to do second, and then you hit list 1, and this is where if you didn't have a list 1, 2, or 3, like whatever your first list is that has the scores in it here, that's what you're going to put here. So if yours is list 4 and list 5, you'd put L4 and L5. But ours, we're going to do list 1, and you put a comma, and then you do second, and then you do, see how there's a little L2 right there? And there's list 2. And now we're going to calculate. Okay? So again, we're going to assume that these are all the possible scores. So we're going to take this one down here. I call that the super O. Again, I know that it's got an actual name, but I like super O better because it's like an O with a little cape on it, so it's super O. So our standard deviation then would be 2.382. So the standard deviation equals 2.8, I forgot already, 382. Alright, so found our standard deviation, and we're good to go on that. Alright, let's try one more with a little bit different type of question, and away we go. We're going to find the standard deviation again. Only thing different here is that we have, instead of like actual scores here, we have this frequency distribution, right? Okay, so what we're going to do here is on this continuous type data here, that's what this is called when you have from 0 to 9. When you have this continuous data here, what we're going to do is we're going to find the average of these. So the average of 0 to 9 is just 4.5. Okay, so this is going to turn into 4.5. That's going to be what, 15.5? 15.5, and then we have 25.5, 35.5, 45.5, 55.5, oops, 65.5, 75.5, oops, 5s. Sorry, I'm getting a little ahead of myself. 85.5 and 95.5. 5, not 9. Okay. So we have all those, and then we're going to put our frequency next to it. 1, 2, 4, 11, 16, 24, 13, 6, and 2. And I'm just getting all that data from right here. Okay. And now we go back in and do the exact same thing on our calculator where we enter in all that data. So we're going to edit, go up to the top, we don't want that one, and you have to push down, go over, highlight list 1, clear it, and go down, and then we're going to enter in all these pieces of data here. 4.5, uh-oh, I put 15, all these should be 4s. Sorry about that. That is a big fat mess. Let's just make this right. Alright, I can erase all these and put in what they're actually supposed to be. Sorry about that. Okay. So this one is 4, 14, 24.5, 34.5, so forth and so on. Okay, so we're going to put all that in our calculator. Oops. Okay, so there's all of this column here, and then we just got to enter in our frequency in the next column. So 1, 1, 2, 4, 11, 16, 24, 13, 6, and 2. Okay? And then we just do what we did before. We just go back into stat. We're going to calculate. We got one variable stats, and again we have two lists of data, so we do second, and then we do list 1. Oh, that's not what I wanted. I'll go back, do that again. I forgot to put list 2 in there. So one variable stats, second list 1, comma, and then second list 2, and then we hit enter. And here is, again, we're assuming that this is all the entire population, so we use a super O X here, and we get that our standard deviation is 16.81. So 16.81 standard deviation. 16.81. All right, so that's all there is there for standard deviation. Again, it's much easier to use your calculator, so use that graphing calculator. And you can, if you don't happen to have one at home, you can just type in TI-81 emulator into Google, and you should be able to find some that will work just fine. All right, thanks. If you have any questions, feel free to ask.